Good evening all. Thank you for joining this session. First of all, I will brief about myself. My name is Sarin. I do have around 8 years of experience in testing. I started as a manual tester, then I learned Selenium automation, post which for the last 3 years I am working in Latvia in different firms. I was part of Accenture first, and right now for the last couple of months I am associated with Citico. And the topic that I am going to present here, I have been doing this for the last 3 months only, so I am not that expertise in what is going to happen here and explain here, but I am always welcome to take the questions. So back in India, I used to train QA engineers. I used to train college students about manual testing and about Selenium and Java, and so I do have small teaching experience, so I think that I can explain the things in the very basic form in which the audience can understand it. And towards the end of this session, my expectation is like having a basic idea on how we can test LLMs, like large language models, especially with RAG-LLMs. So to understand how we can test these kind of models, we need to understand what these models are all about. So I will try to explain about the models first, and then we together will find the areas where we can implement our test cases and run the test cases towards the end of the session. So starting with the agenda, I will give an example of an LLM model that I have chosen for this session, and understanding what a RAG architecture is. And so if you have noticed my heading, I have named it as evaluation rather than testing. Any idea why I have named it as RAG-LLM evaluation and not testing? Anyone?
Well, basically you can't reproduce any output out of LLMs. If you ask some question, you won't get the same answer all the time.
Yes, yes, because it's like not the actual and expected results that we write in a manual test cases. So that's why I have written it as evaluation. So for evaluating, I need different matrices. So I have listed down few matrices also, which we will be using for evaluating this model. So towards the end, we have written some manual test cases for testing this model, and towards the end we will see how we can automate these test cases with help of some libraries known as RAGAS and using Pytest. So let's start with LLM models. I'm not going to explain what this is all about because everyone in the room knows all these models. And yesterday something happened big in the side of OpenAI. Is anyone aware about what happened yesterday? Open source model had come. So I think the future is, so it's my instinct. What I think is many of the organizations is going to adopt this RAG-LLM models. So why they will go for this RAG-LLM models is, what I have read is most of the organizations have many proprietary data that they don't want to share outside. They want to keep it inside, and they don't want to tell or others what they are doing. In order to do those kind of activities, they need to have these models inside their organization. To put it inside their organization, the best model that they can build within their organization is this RAG-LLM models. So let's see how the architecture of this looks like. If I go to, this is how it looks like. So we have proprietary data. So what you mean by proprietary data is, if I am a travel agent running a travel agency, I will feed it with a list of all the destinations to this embedding model, which will be stored in the vector database. So when the user asks questions, what my model will do is, it will think that, okay, I am a travel agent, I need to answer those questions based on like acting as a travel agent. So similarly, if it's a proprietary data, if I'm feeding it with data from a hospital side, a banking side, so our model will act as those agents from the banking side or from the hospital side. So the response will be more user friendly, and the users will be able to feel like a real agent is sitting in front of them and answering those questions. So This is one of the architecture of RAG-LLM, where we have this embedding model and vector database. If you see, I am passing the proprietary data to the embedding model and the vector database, and the same happens for the questions also. So if I raise a question, if a user is asking a question, that goes to the embedding model and to the vector database, and the proprietary data is also passing through embedding model and the vector database. Anyone can figure it out why I am doing this, or why the model is done like this. Both the question and the proprietary data is passed through embedding model and the vector database. Any idea? So yeah, please.
You can do more easily search.
Exactly. And the matching. So basically what happens in the vector database, it's not like a normal database. If I ask a question like, is Latvia in Eastern Europe, if that is my question, so it will go to the embedding model and it will store in the vector database. So when it gets stored in the vector database, how it is going to get stored is, Latvia, whether Latvia is in Eastern Europe, it will be next to Riga is the capital of Latvia. So when the LLM give back the answer will be like, yes, Latvia is in Eastern Europe and the capital is Riga. So that is what is happening in the vector database. So that is why we are using vector database. So when I send lot of data from Emergent, from this Emergent organization, you have many data related to the HR policies and all. So all these data which are related will be stored close to each other. So when we retrieve it, we'll get it like a sequence of sentences which are like sequence of words which are related. So that is why we are using vector database. Now let's see in which all points we can write test cases for this model. So basically what this model will do is, I have given lot of data which will be in the vector database. So when I ask the question, it will fetch these documents with the help of an LLM model. It will frame good sentences and throw me back. So that is what is happening in RAG-LLM architecture. So what LLM model it is going to use is, if I would say, since we have released OpenAI OSS 120, so maybe you can use that model, or you can use ChatGPT 4.0, whatever model you have license, you can use it here. So what this LLM will do is, it will make the sentences feel more beautiful and it will humanize the content more beautiful. So that is why we are using LLM along with RAG. So what RAG is doing is, RAG, anyone can explain the full form of RAG?
Retrieval augmented generation.
So what is happening here is, it is retrieving the files. What it is going to generate depends upon what I am augmenting. So what I am augmenting here is, I will frame the sentences like, is Latvia in Eastern Europe, or is Delhi the capital of India, where can I find good hotels. So those are the augmentations that I will be providing sitting in here. And based on my augmentation, what the proprietary data does is, it will fetch all the files that will have this information, and when it answers, what it will do is, it will answer my question. Along with that, it will throw me all the files which it has referred for bringing up these answers, which means I can make sure that this RAG-LLM model does not hallucinate. It does not come up with vague answers. Whatever answer it is putting in front, it has evidences for that. So I can show you that in the couple of slides, so how it works. So like mentioned, retrieval, augmentation and generation. So we have three phases. So this is where the retrieval happens, and this is where the augmentation happens, and this is where the generation happens, which means we have three testing scope. We can test this LLM at the retrieval phase, we can test it at the augmentation phase, and we can test it at the generation phase. So that is what we will be doing in the next couple of slides. If you have any questions, I'm open to the questions. Don't wait for the end. If you have any questions related to that. Yeah.
Maybe you have some strategies. For example, there are some keywords in this in this data. For example, if the user wants to search for, I don't know, it's movie theaters in Stockholm, and then, for example, the RAG database somehow matches not movie theaters in Stockholm but in Helsinki, because maybe the database is not, the data is not enough or something. Do you have some strategies just to make some attention mechanisms to these specific words which you are trying, which are most important for this matching mechanism?
So first of all, it's a really good question. So I will go back to why I introduced or why this architecture is having LLM here. So this LLM is trained on a general big data set. So if you are asking some question and if it is not able to find the specific answer, what do you expect? Do you expect the LLM to say that I don't know the answer, or do you want to get some answer?
Better would be the first variant.
Don't know the answer.
Yes.
But I have done a survey on this, and most of the people says that we need an answer from the LLM. It's not like wrong answer. You are searching for some theaters in Sweden or whatever. So it will suggest some theaters, but not the best one, not the prettiest one, not the cheapest one. It will suggest, and it will also suggest more about other theaters which are located nearby or outside Sweden, because the proprietary data is more about other countries and not from the Sweden. So most of the RAG-LLM models, what they will do is they will answer you, but that answer may not be appropriate. So there comes how we test the retrieval part. So in this case, if you ask me what is the retrieval score of this model, I would say like it is less than 0.5, because it has lot of documents, but most of the documents were not relevant because it was not able to give a proper answer, which was, or like a more precise answer that we were expecting for. So we have a metrics for calculating that value also. So moving to
Sorry,
yeah.
I have a little answer already for my question.
Okay.
I was just asking, maybe you have an answer to this.
Okay.
So basically, you feed this original question for LLM to extract specific, for example, keywords, and then you try to match these keywords with the information you retrieved. So basically, you somehow extract the most important information, and then you compare that, whether that makes some sense or not, and
yes.
then
Exactly. So there, that comes at the final stage. Whatever result we have, so we will do one kind of testing here also. So I'll come to that. So whether that answer that we got is what we were expecting, or so we have one term for that. I will explain it in the next couple of slides. So so based on so far what we have seen, traditional software testing is all about what the actual and expected result. But when it comes to LLM, it's all about evaluating the LLM model, setting the benchmark. For example, OpenAI 4.0 or ChatGPT 4.0 is way better than Gemini. So that comparison is being done when we go for the LLM testing. So common benchmarks. So here comes what you have said, the factual correctness. So going back, we will do that in this stage. After getting the answer, we will check how much factually correct the answer was. So these are the different matrices that will be used in RAG-LLM model. So context precision, context recall, faithfulness, response relevancy, and factual correctness. But I will try to concentrate on these 2 points today. So what is context precision? So how can we do the context precision? So this is how we can do that. We had lot of documents. So when we call the model, we got some documents like we got 5 documents, out of 3 are relevant, two of the documents were irrelevant, which means the precision was 60%. Going back to the previous question asked, we were searching for the theaters in Sweden, but most of the documents, like we got 5 documents, out of that 3 of the documents were only having the theater details of Sweden, 2 of the documents were of no use. So which means the precision went down to 60%. So this is how we do that. Going back again, so this is one benchmark with which we can access the model, and I can show you how it is done. So we have seen the architecture. So if you ask me to show a RAG-LLM model, I have one in front of me. So this is hosted by one person known as Rahul. What it is trained with is, it is trained with lot of various testing courses and testing courses details. So if I ask a question like, let me ask a question like,
Sorry, I think there's a menu from the display there.
yeah,
Yeah, maybe you should.
You should just close that remote console. Yeah, back button or something.
yeah.
Yeah, oh, yes.
It's good.
Okay, so this model that I'm showing here is trained on a very limited data. So you can't ask a lot of questions. You can just ask these 3 questions that have been listed here. So our purpose is not finding the answers. The point is, our purpose is not finding the answer. Our purpose is to test what we are getting back.
This
Is
is coded.
Actually, it was I didn't do anything here. I just borrowed it from some random person and I'm using it here. So let's ask.
It's so shitty. He writes all of the automation trainings in
So what we learned from Postman API and all, if I'm clicking it here, this is the response that we'll get. So I want to ask another question. Let me ask a question. So this was another question that I have asked. Maybe I will take from the answer. I will get the same response from the model also. How many articles in Selenium WebDriver Python course?
23.
So what I'm trying to do here is, I did the same from the backend. I asked the same question. See, it gave me the answer. Answer is not the matter. Along with the answer, it gave me the file names. It gave me 4 file names, and out of which, see, the first file name, Selenium WebDriver with Python from scratch and framework. That is relevant to my question. What about the next one? Selenium WebDriver with java.doc. That was the file, and I didn't ask for the file, but my RAG-LLM model gave me that file also. Let's move to the next file. That is also related to Python from scratch with framework, and the last one is also Python from scratch with framework. So it gave me answer with 3 referring 4 files. Out of 3, the 3 were only the relevant file. The one was not relevant, which means going back to our context recall. I am doing all this to explain this context recall, which means number of relevant document were only 3, out of which we got 4 documents. So it's like 3 by 4 into 100. So that is what the context recall is. So for that, if a model which is having a context recall of around 60% is not considered a good model, basically they will keep the standard like 80 or 90 above. So this is one way of testing the model, which is the metrics is context recall. And any questions? Don't tell me that everything was hard-coded. I was trying to explain how I am testing it. It's not like whatever the model is, I don't care about that. So this is one matrix that we will use to test the model based on the data or the files that is getting. recalled. If you are all good, I will go to the next one. So the next one is content precision. So if you know one matrix, if you can test one, you can prepare test cases and go for one, then the other one are also almost the same. So context precision is like the number of relevant documents. Sorry, I think I messed it. Okay, context recall. So context recall is number of relevant documents retrieved by total number of relevant documents. What if my model was having 10 relevant documents and that model gave me only 3? I will repeat it. It was having 10, but that liar told me he has only 3.
So 30% recall?
Yeah, which means it was not giving me all the documents. It was not referring all the documents for giving me an answer.
Isn't that sometimes a feature though, given limited context length?
Giving limited, but okay, isn't it feature like?
For example, for LLMs you have limited context length, so always retrieving all of the documents could be too much.
Too much, that is correct.
So I'm just wondering, isn't that sometimes a feature that not all are retrieved?
Okay.
Is that something you test for?
I will test that, but I think then these two tests are interlinked. The faithfulness and factual correctness. Referring 3 documents, if it is giving me more than 90% for faithfulness and factual correctness, I'm okay with it. But referring 3 documents, if I'm getting less score for these 2 matrices, then I'm not okay with that. So it's all interlinked. So you can refer 3 documents, give me good faithfulness and factual correctness. I'm good. So, any other questions? So that is how context recall works. So going back to the architecture, if I ask you where we can place context recall, the answer should be here. So we are still here. We are based on the retrieved documents. We are checking like how much documents retrieved and whether the retrieved documents are of any use or not. So we are still testing the retrieval phase only. So let's move forward and try to test. What is this? Sorry. Faithfulness, response, relevancy, and factual correctness. So after getting the response only, we will be able to test these 3 points. So factual correctness, response, relevancy, and faithfulness is like how can I decide whether the given answer is factually correct or whether it is faithful? The LLM has given me an answer, but how can I decide whether the answer is?
Can you help me understand what's the difference between faithfulness and factual correctness?
The factual correctness, for example, if I am asking a question to the LLM, right, like, where is France? Where is France?
Yes.
So it gave me an answer like France is in Europe and Berlin is its capital.
So factually correct, but faithfulness then?
Faithfulness, basically if I want to explain faithfulness, so that also comes under the last stage where I am getting the answers, but I will cross check with the question that the user has asked whether it is like I can rely on the answer, how much I can rely on the answer. That is the faithfulness. Basically,
subjective, you mean?
I think I get what you mean. I think the difference between those, and tell me if I'm incorrect, is that whether the LLM is actually answering the question, and then the correctness is whether the question is accurate.
Accurate.
Yeah.
If I'm taking a real world example, faithfulness is like.
I think you have, a really good example in your speech because the weights, like it wasn't incorrect. It was it's LLM sold us this idea really good, but the actual correctness was not there.
Yeah, maybe.
Faithful but not correct.
Faithful would not be the right word. I would think faithfulness is like you ask him how to save the world, that he is making a bomb.
Not very faithful.
Okay, that's a tricky question. But yeah, so anyway, I'm not the one who has defined the matrices. The matrices were already there in the Google. I just took it and put it, and I have tested it. But I was trying to understand the difference mainly between context precision and context recall, because when I tried with the model, if I'm getting good responsive for these two, naturally these two were, in most of the cases, the other values were always high. If they were referring most of the documents and if they were referring the right documents, I was getting good score for faithfulness and factual correctness. So that is how that is why I gave more importance for these 2 points, and I just kept this one aside. Moving to the next big part. So let me sum it up. We have seen the architecture, we have seen the testing approach, we have seen the matrices. Testing approach means in what all areas. If someone asks you in which all areas you will test for an LLM, you can say that I will test in retrieval phase, I will test it in augmentation phase, I will test it in generation phase. So, and the evaluation matrices also we have seen. And the next big question is, do we need to automate this or not? Can we do this manually every time? Do we need to automate this one? Yes.
I see the benefit in automation, yes.
Yes. Why? Because initially I feed it with 20 documents, and the 20 documents were only referred. What if I'm increasing the count of documents that I'm feeding the LLM? 300 documents, 400 documents, 500. I can't sit and count the documents and the relevant documents and take it and get this indexes. So there comes the importance of automation. So the technologies that has been used here is Pytest, Python, and LangChain OpenAI. So RAGAS is a library which will help us to communicate with the large language models. So I have written one test case here. So this is how it looks like. So you need to have Python at least 3.13. If you are using older one, it won't help you to have this dependency wrapper for LLM context precision and LangChain. So at least the request is use it for 3.13, and this is a simple Pytest. But let's see how this is being done here. So I asked the same question. The input is how many articles. So the response is 23. So I have retrieved, I have given the context also here. If you see, I have given whatever response I have got, I have given that context also from these responses, and based on that, it will calculate a score and it will print it to me. So right now I had given it as static variables, but what you can do is you can call the API, get the response and put it in arrays and use it. But right now I have given it statically. And can I run it? No. Can I run it?
Just do it.
No, I can't run it. I can't run it. What I was testing here was precision without reference. Leave it. The context precision. If you remember what context precision is, let's go back. What is context precision? Number of relevant documents. How can I code and tell which are relevant documents or not? Is it possible?
Just guess, this is correct, this is incorrect.
No, I can't write a piece of code and check which is a relevant document or not. Any workaround?
prepare the documents that you upload in the database so you know.
I will just ask ChatGPT, tell me whether this is relevant or
Seems like the best approach.
not. Yeah, I will just ask another ChatGPT, tell me whether these documents that this AI has shared me is relevant or not. That's it.
Test LLM was another LLM.
Ah, yeah. Why couldn't I do that? I will do that. Test an LLM with another LLM. So that is what I'm doing here also. So that is what I'm doing here also. I'm using
What if they are
ChatGPT.
both wrong?
Oh, sorry.
What if they are both wrong? They both think it's relevant, but it's not.
I can't do it. Basically.
So users will find it so.
Basically, no one will sit and read all those 50 or 70 documents to check its relevancy.
But
This is the best
if you're
approach.
testing the relevancy,
Uh-huh.
its capabilities to find relevancy, then it makes sense to me to create a database where you are aware of how many documents should be relevant, so you can ask them appropriate questions.
So this is automation. What if I'm increasing the count of the documents the next time?
But automation for checking that accuracy, sure, but if you want to check the engine and know how well the relevancy works, that's like a step even before that.
You can think about that.
Yeah.
Right, yeah. Rather than using a ChatGPT.
Yeah, just to establish a baseline. Not for all of the tests, clearly, no, that's not for all of the tests, but you have to have some confidence, because they raised a really good point. What if both of them think it's right and it's not? We would never know.
But then with ChatGPT, for example, what do you do when there are partially the documents are, let's say, the same, but in some parts they differ. So, and ChatGPT has these hallucinations where it thinks, wow, this is the same, and then at the same time, oh, not
Not that accurate.
How can you do that?
But if you see, when I think about this solution, what I was keeping in mind, or what I was, why I ended up here was seeing this page content. See, file name was Selenium WebDriver with Python from scratch plus framework doc. So this is exactly what I asked for. So the relevancy is like, it's subjective. It's not, it depends on, see, the other file was having something about Java. I didn't ask for that. So a basic model would be able to distinguish between these two files. That was the assumption that I took when this was the approach that was
You have
brought up.
very good clusters of your data, but if their data is more in some place.
So I am trying to wind it off. So this is something, don't ask me to run the test case. I don't have an API key to do that. So basically, purposefully I didn't purchase an API key, because if you ask me to run it, I can show you how it looks like. It will ask me an API key, and that is how it will end up. So,
We believe you, we see the
authentication, right?
Yeah.
No authentication. So I don't have the authentication. I had the Perplexity 1-year plan, but it's not working in Europe. I don't know why. So this is something small from my side, and thanks for teaching me also a lot of things, and thanks for the good questions. Anything else?